Another thing you can be asked in projectile motion questions is the time of flight of the projectile. Once again, there's a couple of assumptions or a couple of key points you need to remember. The total time, or the time of flight, is equal to twice the time it takes to get to A, where A is the top of the projectile trajectory. So if we can determine how long the projectile takes to get to this point, we can simply multiply that by 2 and gives you the total time spent in the air. Now previously we have discussed that at A, the vertical velocity is equal to 0 meters per second. Basically the ball or the projectile comes up and instantaneously is at 0, its vertical velocity is at 0 in position A, which occurs at maximum height. Rightio, so let's, another thing we've got to, a key point is that we are working in the vertical dimension, which means that we are using subscript y. So any data we put down must be in the vertical direction, or to do with the vertical dimension, I should say. So over here we have Vy is equal to 0 meters per second, as discussed over here. Uy is going to equal to u cos, sorry, not u cos, I should say u sine theta, which is going to be 100 sine 30 degrees, which will equal 50 meters per second up. We have acceleration due to gravity, which is going to be minus 9.8 meters. I used arrow there to indicate positive, but really I didn't have to, because the positive means in up direction as the negative means in the down direction. The time we're trying to find out. Notice when we talk about time, we do not put a subscript. Now time is common to both dimensions. I guess it's the one quantity that ties the both dimensions together, and you'll see this when we talk about calculating the range later on, so there's no need to put a subscript there for the t. Righto, so we've got values of v, u, a and t. From the three equations of motion, you would select v is equal to u plus at. Now we are working in the y dimension, so we must apply that to the y. Then we just substitute into that. We have 0, 50 plus minus 9.8 t. Move the minus 9.8 t on the other side, get rid of the negative sign. 50 divided by 9.8, which is equal to 5.10 seconds. Now remember that is the time it takes to get to the maximum height here. We've got to double that for the total time. So total time is equals to 2 times 5.10, comes out to be 10.20 seconds. Now we have just calculated the time of flight of the projectile from this point all the way through to that point over here is going to equal to 10.20 seconds.